Hello everyone and welcome to the BBSim Scalability Brigade for December 13, 2019. We have three topics on the agenda that I would like to discuss. One was, if I remember correctly, there was a proposal from Serkant to create an hashing algorithm to distribute the ONUs across different Kafka partition. But I don't think Serkant is online, so if he shows up, we can come back to this later. The second point is that I wanted to give an update on the scale testing we're doing with BBSim and Volta at ONF. Yesterday, we finally reached a number closer to the 100 ONUs that Netsia was reporting. To arrive there, we have two very small patches. One is in the OpenOlt adapter, and one is in BBSim. What these two patches are doing is basically to keep sending discovery indication if the ONU is not activated. This is the same thing that the hardware is done, but until now, the OpenOlt adapter was considering only one discovery message for ONU. With this patch, if the first one doesn't go to completion, then we accept a second or a third discovery message. While doing this, I noticed that even though we have a bigger number of ONUs being activated, we still have issues with the flows. All the flows in ONOS are stuck in status pending add, even though they make their way to BBSim. Just the OpenFlow adapter times out before responding to ONOS. So I think in general we have some issues in managing the RPCs over Kafka, meaning that I've seen few places in which the RPC fails because of a timeout, but being the message on the bus, the client will pick it up and operate on it. So it's actually not not failing.
And this is for any of the Kafka-based messaging between core and adapter, or between two adapters.
Yeah, I haven't investigated every single message, but I've seen this happening in few places because the first place in which I've seen it happening was in the OpenOlt adapter when we called the get child detected. So, for example, when we
that was the patch.
Yeah, when we call this child device detected, um, this command actually fails because of a timeout. But the device will be actually detected by the OpenONU adapter and by the core. So the next time this comes around, yeah.
Do you happen to know what that timeout was? I guess it's just a gRPC default timeout, or is it something that we set?
I think it's the
or I guess it wouldn't be gRPC.
No, I think we're setting a default timeout
whatever.
1 second.
Yeah, I was just going to say I thought it was gRPC, but given it's over Kafka, it's probably some other defined timeout.
Yeah, if I remember correctly, jumping around in the code, I've seen somewhere that we're setting a 10 seconds timeout. And then that's consistent with what I see in the logs. So I don't know if this is an issue that we have everywhere. but I've seen it happening when the system is busy. I don't see it happening when we're running one or two ONUs, because every piece of the system responds quickly enough. But when you start stressing one part of the system, then you have these basically queues of events in Kafka that get processed one by one, and all these timeouts fail.
So this may be what Mihir was mentioning about in the core, having to adjust some of the caching settings. Because 10 seconds is an awful long time. So yeah, I guess, I don't know if he has that patch somewhere or what he had tried to change in the core to speed that up. One way, obviously, like you've done, is to just have it, if it fails, try again, which is a good idea to do. But the other side of it too is, why on earth is it taking more than 10 seconds to interact with the core when it's busy?
Yeah. These are definitely like two parallel aspects. One is to make it more robust to failure, and the other one is to make it faster. Because I think that the value of gRPC.
Yeah, this one might be.
Oh, go ahead, man.
I was just going to say, this might be one place where we might, if we can get it something easily reproducible, we can get Ken to look at it. I know Ken has probably spent a lot of time in that space, and I know Mihir and Ken have gone back and forth on some of the approaches, but maybe if we had a really clear way of demonstrating it, it might make it easier to solve.
Well, yeah, with bringing up 100 ONUs, I see this timeout happening all the time.
Okay.
So I can ping Ken. I tried. So I think Maira has a patch somewhere, but I tried to get in touch with him this week without any success to see if he can share the patch. So I don't know. I haven't seen it yet.
Yeah, he mentioned it in an email. I can't find it in Garrett either. Okay.
Yeah, and he also.
All right, but in any case, your patch is good for having it try again. So I think that should be fine.
Yeah, so this should also cover another like corner case, that is when the OLT comes up, the core is restarting for some reason. So this call will time out because the core is not actually there. But then when the core comes up, it will process the event on Kafka and will be in the same situation as a long timeout. Okay, so the last.
Cool.
The last point I had for today was this memory leak that Scott found yesterday. So basically, there was a very short discussion about this on Volta stabilization, but it was a problem with restarting the OpenOlt adapter. When that happens, the gRPC stream is never successfully restored between BBSim and the adapter. And so the adapter keeps sending enable request, but BBSim is not able to reply to the adapter. And also anytime it receives a new enabler request, it will start a new thread. So after a while that this happens, the machine on which everything is running is not very happy. So this is something we need to investigate pretty soon. And I'm going to create a Jira today to track this down. So given that no one from Nets is on the line, I think we'll have to postpone the Kafka partition discussion to the next meeting. And I don't have any other topic for today. Is there something else that we need to discuss?
Hey, Matteo.
Yeah.
I just have a quick question. So, in BBSim, I guess there was a fix just to basically add the continuously sending discovery message until the ONU has been accepted, right?
Yeah.
So, has anyone tried? If we let's say we say we limit the number of discovery messages to let's say 1 per 10 seconds, or even longer, right? I mean,
Oh yeah.
does the system come up reliably in that case,
So
or we still see the same kind of issue?
so the issue is clearly smaller, but as now BBSim is sending 1 indication per minute.
Per minute. So even that is more or less often than the actual hardware sends it. I think Agent and Val, I don't know if it's configurable. It'd be nice to know if it is, but I think by default it sends it every either 1 or 2 seconds.
Yeah. So
I think it's in reality it's governed by the ranging windows and when the ONUs are discovered, right? I mean that's probably the driver, but so in the case where let's say you send a discovery message every 1 minute, so basically the discovery message is going into the OLT adapter, and then basically we can look at Matt's message sequence diagrams, which were great, by the way. So we can see that all the processes that occur after that discovery message has been seen, the ONU is adopted, it's notified to the the core, etc. Right. So if I get one message in that's like that, it would go through the normal process and be adopted, and things would operate normal as we would expect, I assume, right? And then there's a delay, and then another discovery message comes in. Is there a threshold? Is there a limit where things start to go bad? I mean, if you have, just based on the time between the discovery messages being generated and sent to the OLT adapter, I mean, how does that control the timeout and the errors that we see?
But so what happens is not that we are bringing up 1 ONU per minute. What happens is that all the news that have not been enabled will send a new discovery indication after a minute. So it's still it's still a bulk.
Yeah, I guess I'm not asking for that particular use case, right? So I'm just asking, let's say BBSim, we make it just very slow, right? So I can only generate a new discovery message, let's say once every 10 seconds, right? Which for 1,000 ONUs is going to take you 2 hours to get through 1,000, right? But let's say we just have BBSim generate a new discovery message every 10 seconds.
I haven't tried with that.
Is the system stable at that rate or no?
So I haven't tried with such a long delay. We tried with a 2 seconds delay, but even with that, I wasn't able to arrive to more than 35 without sending new retries.
Yeah, I'd be very interested to know if we extend that time between generating discovery messages. So, is there a point at which the system behaves, well? It's in a very stable way. It can accept a particular rate of discovery messages coming in.
I can try.
Something else to keep in mind as well is for any one ONU, currently it does send an indication, discovery indication once every couple of seconds for any one ONU. So if there happen to be 5 plugged in, all 5 of them will send their individual indications every 2 seconds.
That's right, but we don't have to accept those, right? I mean, we can just ignore them; they'll just keep going,
correct.
Right? I mean,
if
you ignore it, they'll eventually get picked up once we, handle what the ONU we're currently working on.
I see. So work them in batches. So maybe work them in batches of 10, and then you can kind of ease your way into bringing them on without having to accept all 100 of them.
Yeah. So I guess what's the threshold at which the system behaves well? I guess. I mean, if we slow everything down so that I'm only handling an ONU discovery every 10 seconds, is that slow enough for the system to be stable and handle 1,000 after 2 hours or whatever, right?
So I don't think so, but I can try. What I've seen is that so what I've seen is that after a certain number of ONUs, there are other things going on in the system together with OMCI that eventually slow him down enough that new ONUs maybe they'll eventually come up.
Yeah. So I mean, really, but and once you reach a steady state, like so, all the ONUs have been discovered, they've been lip-synced, they've been provisioned. At that point, the only really thing that should be going on is basically a PM collection, right, from the ONUs. I mean, there should really be nothing else going on, so we don't really need to talk to the ONUs, right?
But for example, ONOS tried to push down the flows for all the uniports for each ONUs, and no one ever acknowledged ONOS that those flows had been accepted, so ONOS will keep sending them.
Oh, well, that's another problem.
So okay. The point I think here that's interesting is if we stagger the indications by some grouping mechanism, right? The OLT can queue them up as well, the adapter. Once all of the initial provisioning is done, including pushing flows, initial flows for unis, it is like you said, once the flows are pushed, they're accepted, OMCI is sent, the flows are in BAL. It's really just PM intervals every 60 seconds or so, collecting a handful of MEs for statistics. I guess the goal that we set out, I think for the Tiger team was, I think 515 minutes. So if we have to rearrange some of the timings to make that work, to work around some things, I think we could still accomplish that.
Well, I think that if we could just establish what that threshold is, and if we could say, okay, I can handle one discovery every 10 seconds or 5 seconds or whatever that happens to be, right? I mean, if we can eventually get to the point where, let's say, every 2 seconds we can handle a new ONU. Let's say, in that case, we can bring up a whole ONU in 30 seconds, which is not 30 seconds, but 30 minutes, right? 1,000 ONUs, which is probably not bad, right? I think that is meets the Tiger team goal, I would imagine.
I tried with a second delay between ONUs, and that is not enough to get more than 35 or so.
Right, but if you're handling one ONU at a time exclusively, and we're just ignoring or we're holding off the discovery messages.
Yeah,
nothing happens.
That was sending the first discovery every 2 seconds. So that was basically
right. But let's say extend that out, because 2 seconds is not enough. Yeah. Two seconds is not enough, right? So if let's say we start at 10 seconds, does that allow the system to come up and function and get to that steady state point where all the ONUs are configured?
I can try that and see what happens. Yeah,
and if it still goes bad, then just extend that out until we reach a point where, let's say every 1 minute you discover a new ONT and the system comes up and functions. Can we at least get to the point where we know what the rate of discovery is of ONUs that the system can handle? I guess. I mean, obviously there's some timeouts are going on, and the contention of concurrency is really not allowing the system to function, right? So let's just slow that down and find out what that threshold is.
Yeah. No, this is something William and I talked about a little bit. Just, regardless of what it is, let's say, we slow it down, like you said, some ridiculous interval. Will it eventually get to 500 in 2 hours? What's the what does it take? Does it eventually get there if you go really slow? I think, knowing that.
Yeah, so 20 seconds is 2 hours for 500, right? But a 20-second interval. But I can't imagine the system can't handle one ONU every 20 seconds. I mean, something is really fundamentally wrong.
Right. But I think the point of that is it should be completely deterministic, right? Like you said, if we do the math, then it should exactly take that amount of time. And if for whatever reason it doesn't, then there's something else, much more fundamental we need to look at.
Right. And if we reduce the things that are going on, we might be able to find what that is, right?
Yeah, I mean, fair point. I think that it's a good data point to kind of help drive out some of the concurrency issues.
I can make a run with that today and see which kind of result do I get.
Okay, that sounds great. Thanks.
Hi, Matteo. This is regarding the IGMP support for BBSim.
Yep.
Okay, so we have submitted a new patch regarding the leave request from a BBSim to ONUs, and we have seen that the leave request has been successfully executing. And we have some queries regarding the IGMP states in the code. So my first query is that how do we confirm that whether the IGMP request, the membership report, has been successfully reached into ONOS, without looking into the ONOS logs. Like if there is a response that is giving back from that ONOS to BBSim or not.
So I think when you send an IGMP packet to ONUS, you should receive something back.
Okay, so we haven't implemented a code for that. So we will try to look into more documentation of IGMPs to see which type of responses it is giving back. And my second query is regarding the states, mapping of the states. Since if currently using two states for now, IGMP start and IGMP leave. These two states are we using for right now to control the states while you executing the IGMP commands from BBSim. So shouldn't we use map these states, IGMP states, to other source states as well?
I'm not sure I understood the question.
Suppose like if I execute an IGMP join command right from BBSim,
yeah,
it will change the state of that ONU to IGMP start.
Mm-hmm.
Okay, so if another user, if I again execute an authentication from BBSim for the ONU, it will not it will give some error because this required state for executing that authentication might be different from that IGMP join start, right? So we need to like map this IGMP join start to other source states as well, right?
Yeah, I'm still not sure I got the point. So you say IGMP starts and then something else happen like authentication, and so the state will change. And you don't know anymore in which state the ONU is.
Yes, Matthew. Actually, sources, we see there are multiple states there for DSCP, for OMCI, and for authentication. Okay. So in these sources, we need to add these states for IGMP, which we have, right? Currently, the states which are supported for authentication starts are like enabled, or if EAPOL flow received. So similarly, we should have the states for IGMP as well.
Oh yeah. Yeah, once we figure out what ONOS should send back, we should listen for that event and update the new state accordingly.
Yeah, right. So similarly, like we have around 12 to 13 states currently. Okay, so IGMP states, we have introduced 4 new states here now. They are IGMP start, then one is IGMP done, another is IGMP error, and the fourth one is IGMP leave. So we need to map all of these states in the existing states. So I'll do one thing.
It sounds like the BBSim state machine for IGMP just needs to be fleshed out, right? It just needs more states to represent IGMP. Is that correct?
Yeah, right.
Okay. I mean, yeah, it just sounds like, knowing more about IGMP and then implementing that. I'm not as familiar with it. So again, it's kind of hard to know whether it's right or not, but it sounds like if, we need to have more states to represent the transaction, then, to me, so be it, make it so.
Yeah, agreed.
Okay. So I'll add these states in sources of existing states, okay, for APOL and for DSCP, and then I'll submit another patch. Just have a look at it. If required, I can change that states.
Yeah. So
the only other thing.
Oh, sorry, Matt.
The other thing to keep in mind is the core, obviously, and the adapters aren't fully ready for IGMP or multicast, or not at all, let's say. So it would have to be stubbed out. I don't know if we can really test any of it yet or not. I think the ONOS apps might be further along, but the core and the adapters are not. For what it's worth.
So I think we have seen the IGMP packets at least arriving to ONUs. So that's a good start. I'm not really sure of what the adapter should do differently than a regular packet in, packet out.
It could be. I guess I've just personally not tried sending or submitting an IGMP trap flow. So the core may decompose it properly and send it to the OLT adapter for it to capture it. And if it does, I guess, shame on me for not having tried it. But just putting it out there that I don't know how fully complete it is.
Oh, okay. No, so we have concern about IGMP flows, not IGMP packets.
Yeah, my only comment is really just I don't know the state of that, and if we're trying to test something that hasn't fully been vetted in the core, it might give us false positives or false negatives.
Yeah, makes sense. That's good to know. But I think
that's fine.
Yeah, I think this effort that Arjun and Shubham are doing to add IGMP support in BBSim is to later go and uncover all the places where the support is missing.
Yeah, and again, makes sense. We can get the state machines extended. Just if we actually wanted to do an end-to-end test, is really kind of, I guess maybe a question for me is I don't even know if we're in a state to do any end-to-end testing yet at all with it.
Okay, sounds good. Anyway, Shubham and Arjun, I'll take a look at the patch you have submitted. I think we're in a pretty good state, so if that's okay with you, I'll probably merge this today, and we'll make new changes in a different patch. Does that work?
Yeah, that's fine. And one more thing, the patch which currently we are having, we have used some of the code from Go packet library. So we wanted to take it out and submit in the GitHub of the Go packet library.
Yeah.
Go packet account. So you want us to submit it, before merging it, or we can do it after merging and remove it from the another patch?
We can do it after merging. So just to make everyone aware, Shubham and Arjun, they wrote some extra function to add IGMP support to the Go packet library. For now, those functions are within the BBSim code base, but the plan is to upstream these changes. But I think it's fine to merge these patches, and once the changes are available in the Go packet library, we can just go back and remove that code from BBSim.
Okay.
So I don't know how.
And Matthew, one more.
Yeah.
One last question I'm having. Currently we are using only 2 states. from IGMP, that is IGMP start and IGMP leave. Now we have two more states here, which we decided to discuss on that later. The other states are IGMP done and IGMP failed error. Currently, like when I checked the TCP dump, I have mentioned this thing in mail also. Like we were getting IGMP v3 response back for join request, and same response we are getting for leave request also. Now my question here is, like, we don't know in BBSim, or we don't have the mechanism in BBSim currently to see whether IGMP packet reached BBSim or not. We are handling OMCI messages. So this IGMP packet should come as part of OMCI messages, or there will be some other stream for that?
No, so the IGMP packets, as they are coming from ONOS, they should be coming. There should be a packet out method. I'll send you a pointer for that. But in the OLT, there should be ONU packet out method, and they should show up there. And they are automatically forwarded to the ONU. So on the ONU channel, you'll receive a message that is, I guess, ONU packet out.
Okay.
And and in there, if you see, there is a method that check whether the packet is equal or DHCP and send it to the appropriate responder. You may need to extend that method to check if it is an IGMP packet. And
okay, because based on these messages, based on the IGMP messages we are getting in ONU channel, I want to decide whether my IGMP join request was successful or not. And based on this, I want to change the states.
Yeah, that makes sense.
The two remaining options.
That makes sense. I'll send you the pointers on Slack to these two methods.
Yeah, please. So yeah, that's all from my side, Matteo.
Okay, thanks for the update. Okay, if there isn't anything else that we need to discuss, I think we can get back 20 minutes or so of our live.
Hi all, this is Chidambar. Am I audible?
Hello, welcome.
Yeah, I am a bit new to this brigade. So I am working on the performance of OLT adapter and these things with the BBSim only. So I have few scenarios which I have tested. So I'll just first share those scenarios, and then you can give me some inputs so that I can follow. Like with the both the old BBSim or like an legacy BBSim and the new BBSim, I have different scenarios tested. With increasing the watchdog timer and without increasing those. So with the new BBSim, I have tested around 70 ONUs altogether coming at once, which are getting around 20 ONUs are getting stuck in OMCI starting OMCI state. When I tested for 50 ONUs, all were in good state. All were flows were getting pushed. With legacy Ulta BBSim, where I tested the same scenarios, the same results, but one more test which I have done is like I have started adding the ONUs once they are getting activated. Like per cycle, I used to add 5 ONUs. Then I could reach till around 200 ONUs within 40 minutes of time. So I just have a doubt, what about this? If the ONU is getting stuck in starting OMCI state, what exactly? What I found is ONU adapter is not writing the starting OMCI message to the Kafka channel. So that's what I observed. So is that right, or like is there any other thing which I need to look into?
So starting OpenOMCI reason. So if you actually see that shown in the CLI, the actual reason update to the core at least made it. But just after that is when the bulk of the message exchange for OMCI really starts. So this is ONU sending a message to the OLT adapter to send it to the OLT, to the ONU and back. And each ONU, this is about 300 or so round trips. Along the way, right, other ONUs may be coming up and then interacting with the core and interacting with Kafka. So some of addressing that is kind of the idea of templating a lot of that discovery so that we don't have to discover the same thing over again. But again, yeah, that's starting OpenOMCI and then moving on to finish. There's a lot of messaging that happens there that as the number of ONUs goes up, it can become quite burdensome.
Usually, is it for the MIPS we are doing this starting OMCI, and if that's the case, can we handle it in a different way, like whatever the MIPS we are downloading or uploading, can we do it at the OLT part?
Well, at the do the MIB uploading at the OLT adapter, or question?
We can do it at the OLTA side only, because anyhow we need OLTA can push the required things to the down. So can we have these all MIPS at the OLTA level only, to reduce the traffic of the OMCI?
Sure. So I think this there's a document I think we could probably share that proposes a design to templatize the discovery, right? Because the messaging is the discovery, and per OMCI, we are supposed to go out to every ONU and walk the MIB, do MIB upload next, and discover everything. But what we found is if all the ONUs, let's say 200 of them, are all the exact same make and model, the MIB that is uploaded from the ONU is mostly identical for the from all the other ones. So we don't have to, in that case, perform that upload if we know what we're going to get. But currently that's not the case. Currently the case is to walk the MIB as specified for every ONU. And this interaction does take place in the ONU adapter, and it does construct the OMCI message, and it does remember what was uploaded from the ONU. And it's filling that database, which is really the time-consuming part, that and actually querying the ONU itself.
Yeah, I got it. And if it is there for a very long duration if it is the ONU stuck in for a very long duration in the starting OMCI part only, can we restart the entire transaction by rediscovering the ONU? Is that possible to handle?
It could be. So some of this might be, I know the ITU spec says during the MIB upload sequence, if there hasn't been an answer, I think within a minute, or if there hasn't been another get next or upload next in a minute, it should either forget about that upload attempt and presumably try again. I'm not sure if the library actually does that or not. I think it may, but again, it would just as soon start uploading again and then probably experience the same timeouts. The issue you're probably seeing if you look in the logs is the library in the ONU will send a request and then not get an answer back in, I think, 5 seconds. And then it'll try again, and then it'll try again, and eventually it will give up. I'm just not sure what state it's in when it gives up. When does it start over the whole transaction, the whole upload transaction?
Yeah, I think depending on where it is in the process, it might be just as easy to do a reboot and you'll let the thing be discovered again.
Yeah. So this may be something in the state machine. I know that in the MIBSig state machine, it starts with a reset and then proceeds with upload. I'd have to look at the code to see, but it may be just as easy to say if that upload process doesn't finish, start with a reset again and then just start over.
So the reset is something that happens via OMCI?
Yes, so when an ONU is first discovered, just after it's ranged and the library is handed the ONU and the MIB synchronizer state machine starts, the first step just before MIB upload task is run is the actual sending of an OMCI reset. And this is really just to remove any garbage that may have been on the ONU from a previous boot or whatever the state was before. This is really to start over fresh so we can synchronize.
Okay.
But this reset, what it really does is just clears out any old values.
Okay, but that's an OMCI only operation. It doesn't require any new ONU indication to be sent up to Volta from the OLT, right?
No. It's just the reset. It's okay. But again, given it's over OMCI, if that communication channel is somewhat hindered because of all the other messaging going on right now, even the reset message itself may be delayed in getting to the ONU.
Yep. Yeah, so I haven't verified that, but I'm suspecting that we can be in the situation where the same thing as the lost discovery happened, meaning that it's possible that the ONU adapter will send out an OMCI message, then the response handler will time out, and basically the ONU adapter will never consider the response for that message.
Yeah. If the response eventually comes in and it's timed out, then it's just lost. It's just garbage.
Yeah.
But the MIB synchronizer state machine, if it doesn't get to the in-sync state, it should already be coded to try again. It's just the nature of that try again might need to be adjusted depending on if there are 100 ONUs.
And one more thing, what I observed was whenever the OLT adapter sends the message for OMCS transaction start, when it is received by the ONU adapter and it is failing to respond back to that message, means it is not able to write it into the Kafka topic. So I have observed those ONU start OMCI response was not there in the topic.
Yeah, I'm not surprised. If it's under load, there's a few places in that messaging that start showing issues. So yeah, this is the kind of stuff we need to chase down.
So Chindamara,
sorry.
I think it would be great for these places in which you see messages not being written on the bus and stuff like that. I think it would be good if you can open Jira's so that we can keep track of them.
Sure, I'll do that. Yeah, that's it from my side.
Okay, thanks for sharing this information. I think all of this was very useful, at least for me. Is there something else we need to discuss? Okay, I'll take that as a no. So thank you everyone for joining, and talk to you soon.
Thank you.
Weekend.
Okay, thanks. Bye.
Bye.
Thank you. Bye.